In Chapter 8, we're going to learn exponential and logarithmic functions. But before we can get to that, we are going to look at, in Section 8.1, composite functions and inverse functions. So first we'll look at composite functions. So let's say that f and g are two functions. Then f circle g means f composed with g. This is the composite function. So to make a composite function, you need two other functions. Sometimes you can make a composite function with more than two. But for now, let's just see f and g are two separate functions, and then we compose them together, and we get this f little circle g. And the definition of that is, for f circle g, in parentheses x, is defined by, so that's the function here on the left, f circle g of x. The way we evaluate this is we do f of g of x. And we work this out from the inside out. Okay? So here's a diagram. So we have a machine representation of our function g. And so if we put in here an input x, we get out an output g of x. And then we have this other function f, represented by some sort of machine like this, f. And this g of x, we put that as an input for f, and then the new output we get is f of g of x. Okay? So ultimately, what f of g is doing is it's taking us from this input all the way to f of g of x in one step. So you can think of the composite function as one big function called f composed with g, or f circle g, where we plug in an input, a number like x, and we directly get as an output f of g of x. Okay? And so what this composite function does is that it does the role of both of these functions in one. So let's take a look at an example. So for our first example, let's say we have the function f of x equals 4x minus 3, and g of x is equal to x squared plus 1. So we'd like to find f circle g of 2, and then in part B, we'd like to find g circle f of 2, and then in part C, we'll do part C in a minute. Let's work out part A and B. Okay, so by definition, the way we're going to start is here we're going to put f parentheses g of 2. Okay, now we're going to work this from the inside out. So for my next step, I'm just going to write f and a big parentheses here, because what I need to do is I need to work this out, g of 2. And the way I work out g of 2 is I use the equation or formula for g of 2. Okay, and according to that formula, g of 2 is 2 squared plus 1. So that's f of 4 plus 1 is 5. And then now to work out f of 5, I'm going to look at the formula for f, which is up here. But now the input is 5. So we're going to evaluate that, replacing x with 5. So this is going to be 4 times x plus 1, which is, of course, 4 times 5 plus 1. Or, wait a minute, what was the minus 3? I'm sorry. 4 times 5 minus 3. There we go. So the answer is 20 minus 3 is 17. So in summary, what we've computed is that f composed with g at 2 is equal to 17, and that's the final answer. Okay, let's do the same thing. Let's work out part B, actually. So in part B, again, we start from the definition, which puts g and then parentheses and then f and then the input 2. So here again, we're going to work from the inside out, so I keep the g as is, and we have to work out what f of 2 is. So here we first work out f of 2 because that's the inside, and again we're going to use the formula 4x minus 3. So that puts us at 4 times 2 minus 3, or x is 2 here. So 4 times 2 is 8, minus 3 is 5, so here we have g of 5. Okay, and then to do g of 5, we're going to use the formula for g, okay, which is x squared plus 1, but instead of x, of course, we have 5, so this gives us 5 squared plus 1, 25 plus 1 is 26. So that's the answer. So what we've calculated here is that g of f of 2 is equal to 26. So there's an important lesson here. We're using the same two functions, f and g. We're using the same input in both of these. The input is 2, but the outputs are different. This is not a coincidence. As a matter of fact, f circle g is not equal to g circle f. So the order definitely matters. So you have to get that right. So just want to make that as a cautionary note here. Now let's work one more thing out. And for this, I'm going to copy this to the next page because I want to work out another example with the same function. So over here in part C, we want to calculate f circle f, and the input is -3. Okay? So you can compose a function with itself. So again, just using the definition, we're going to do the same exact thing. F parentheses f of -3. So here we're going to work out the inner function, which is this one here. Okay, so just to distinguish the two, let me work this out in pink. So f of -3 is just 4 times -3 minus 3. That's 4x minus 3. And within the parentheses, so remember, I'm keep writing this outer function until I use it. So that's -12 minus 3 is -15. So this pink part reduces to -15. Okay? Now we're going to plug in -15 for x inside the f function, and we get 4 times -15 minus 3, that's -63. And now that's the answer. That is the answer for f circle f of -3 equals -63. There we go. Okay, so this is about composing functions with numbers that are inputs. Now, in this next example, I would like to show you that you can just build a whole new function. You don't have to keep using the definition over and over again. So in this example, what I'd like to do, I'd like to give you two functions again. Well, let's do 2x plus 7, and g of x will be negative 4x plus 5. Okay? And we're going to calculate a few things. We're going to calculate in part A, f composed with g of x. Okay? And then in part B, we're going to calculate f circle g of 3. Now the calculation for part A is very similar to what we just saw. So using the definition, we can write this as f of g of x, and then just work out the inner function, this one over here. So f of g of x, well, x is just a variable. There's no calculation here. I'll just copy down what g of x is, negative 4x plus 5. Now, I'm going to put this negative 4x plus 5 as an input inside the f function. So the f function, let's just copy it with blanks. 2 times x plus 7. So 2 times the input plus 7, that's the definition of f. And instead of the input x, we have the input negative 4x plus 5. And then, of course, we can simplify this. We can distribute, so we get negative 8x plus 10 plus 7, and that gives us negative 8x plus 17. So in summary, what we've calculated here is that this f circle g of x is negative 8x plus 17. Okay, now make a note of this, because in order to calculate part B asks us to calculate f circle g of 3. Okay? And so now instead of using the definition, to calculate f circle g of 3, I can just use the formula that I just discovered, this formula that I told you to make a note of, negative 8x plus 17. And instead of x as my input, what do we have? Negative 8x plus 17. But instead of the x, I have the input of 3. So I get negative 24 plus 17, negative 7. Great, so we've calculated that f circle g of 3 is equal to negative 7. And let's do one more example before we wrap this topic up. In this example, we're given that f of x is x squared plus 1, and g of x is x plus 1. Now, for part A, we're going to calculate, again, f circle g of x. So let's just do that. That gives us f of g of x, which is f of, just replace g of x with its formula, x plus 1. So that gives us the function f evaluated at x plus 1. Now f of x is x squared plus 1, so that's blank squared plus 1. And instead of the blank, I put in what the input is here, which is x plus 1. That's the f function. So instead of x, I have x plus 1. So if I simplify this, I have x squared plus 2x plus 1 plus 1, which gives us x squared plus 2x plus 2. So this is the answer for f circle G of x equals x squared plus 2x plus 2. So that's the result of the composite function f circle G of x.